Very good morning and welcome to my YouTube channel. We are mechanical engineers. So today we will discuss about the degree of freedom of mechanism. So first let us discuss what is meant by degree of freedom. So degree of freedom, which means the number of independent coordinates required to define the position or motion of a mechanical system in space, right? So the number of independent coordinates required to define the position or motion of the mechanical system, right? So here Kutzbach criteria for planar mechanism, two equations are there, both are similar. See here, n which is equal to 3 into capital N minus 1 minus 2 P1 minus 1 P2, right? So here small n, which is called as a degree of freedom, and capital N is called as number of links, and P1 is called as number of kinematic pairs with 1 degree of freedom, and P2 is number of kinematic pairs with 2 degree of freedom. Or else we can use the simple equation n which is equal to 3 into capital L minus 1 minus 2j minus h, whereas n is number of degree of freedom and L which is equal to number of links and j which is equal to number of lower pairs and small h which is equal to number of higher pairs, right? We can use either this equation or this equation, right? Now the number of degree of freedom n is less than 0, which means it is called as the pre-loaded structure or the superstructure. I mean the given mechanism, the given mechanism, the degree of freedom for the given mechanism is less than 0, then it is called as the pre-loaded structure or superstructure. Whereas the number of degree of freedom which is equal to 0, then that mechanism is called as a structure. Whereas the n is equal to 0, n is equal to 1, then it is called as the constrained mechanism, right? So n is greater than 1, n is greater than 1 which means 2, 3, 4 like that, then it is called as the unconstrained mechanism, right? So n is less than 0, maybe 1, minus 1, minus 2, minus 3, maybe that is called as superstructure, right? So 4 varieties are there. N is less than 0, n is equal to 0, n is equal to 1 and n is greater than 1, right? Now, so 2 degree of freedom, which means the 2 links can move independently, whereas for 1 degree of freedom 1 link can move independently. For a 0 degree of freedom, which means there is no relative motion between the links, it is a structure, right? If the degree of freedom is less than 0, which means the negative side may be minus 1, minus 2, minus 3, right? So the unnecessary links are added to a fully constrained system. It makes the over constrained, right? So normally the designers usually done to reduce the stresses in current links for superstructures. Okay. So now let us try with examples. So this is the first example. Let us consider the 4-bar mechanism. As we know that already the 4-bar mechanism has 4 links. So we know that n which is equal to 3 into n minus 1 minus 2j minus h. This is the equation. We can substitute either this equation or this equation, right? So n which is equal to number of degree of freedom and capital N which is equal to number of links and small l which is equal to lower pair and this is higher pair, right? So let us take this 4-bar mechanism. Already we know that 4-bar mechanism has 4 links. So substitute capital N which is equal to 4. Right, 4 links are there, so n which is equal to 4 and L which is equal to lower pairs. So lower pair, which means it may be a surface contact or a area contact, right? So here the link 1 and link 4 connected at the point A by the pin joint and link 1 and link 2 connected at the point B by the the pin joint, whereas for C and D is also connected by the pin joint. So these 4 joints are area contact point. So these 4 joints are lower pairs, right? So L which is equal to 4. And what about higher pair? If there is a point contact or a line contact comes under the higher pair. In this 4-bar mechanism there is no higher pairs are there. So H which is equal to 0. So substitute these values in this equation, then n which is equal to 3 into capital N 4 minus 1 minus 2 into, so L which is equal to 4 minus 1 into 0. So n which is equal to 3 into 3 minus 2 into 4, 8 minus 0. So 3 into 3 which is equal to 9 minus 8 h which is n which is equal to 1. So, degree of freedom for this 4 bar mechanism which is equal to 1, right. Then now let us take the second example. So, here 5 links are there, link 1, link 2, link 3, link 4 and link 5, totally 5 links are there, right. So, 5 links, 5 pairs. So, this is point A, one pair, because link 1 and link 5 both are joined at point A. This is one lower pair, and B is another lower pair, C is another lower pair, D is another lower pair and E is another lower pair. So, totally 5 lower pairs are there. So, L which is equal to 5. So, number of links n which is equal to how many? 5 links are there, right. Then there is no higher pair. So, h which is equal to 0. So, leave with this h. So, now substitute these two values in the equation. What is called the equation? N which is equal to 3 into capital L which is equal to 5 minus 1 minus 2 into 5. So, which is equal to 3 into 5 minus 1 4 minus 2 5s are 10. So, 3 into 4 12 minus 10. So, n which is equal to 2. So, number of degree of freedom which is equal to 2, which means see here n is greater than 0, which means that particular mechanism is an unconstrained mechanism, whereas for previous case n which is equal to 4, n which is equal to 1, which means it is a constrained motion. So, 4 bar mechanism is a constrained mechanism, and for next one with the mechanism with 5 links, that is n is greater than 1, which is comes under the unconstrained mechanism. Okay. And now let us take 5 different examples. This is the 3 bar mechanism. So, 3 bar mechanism, which means the name itself you know that 3 links are there, link 1, link 2 and link 3, right. So, 3 links are there. How many pairs? Link 1 and link 3 joint at point A. This is also one of the lower pair, and link 1 and link 2 joint at the point B. This is one lower pair, and C is also one of the lower pair. So, how many lower pairs are there? 3 lower pairs. So, L which is equal to 3. How many links? Capital N which is equal to 3. Then substitute there is no higher pair. So, H which is equal to 0, right. So, in these 5 cases there is no higher pairs. So, substitute H value which is equal to 0 for these all the cases, right. Now, for what is the answer? What is the number of degree of freedom for the problem A? N which is equal to what is the formula? N which is equal to 3 into L minus 1, L which is equal to 3, 3 minus 1 which is equal to 2 minus 2 into L. So, 3 2s are 6 minus 3 2s are 6, right. So, n which is equal to 0, which means what? It is a structure, right. See, n which is equal to 3, n which is equal to totally 0. See, this is actually capital N which is equal to number of links. 3 links are there. So, substitute 3, and this is actually 3, right. So, 3 minus 1 minus 2 into L which is equal to number of lower pairs, right. So, this is actually wrong. Equation which is equal to 3 into n minus 1 minus 2 into L. Okay. Let us take for second example. Let us solve second example. Second example, already we know that it is a 4 bar mechanism. So, n which is equal to 1. It is a constrained mechanism, right. So, what about third? Third 5 links are there, already we discussed in our previous slides. So, n which is equal to 2, right. So, this is a structure and this is a constraint and this is an unconstrained mechanism. Then what about the fourth one? 5 bar mechanisms. Totally how many links are there? 5 links are there. So, capital N which is equal to 5 and L which is equal to how many? 1, 2, 3, 4. 4 pairs are there, right. So, 4 lower pairs. So, small n which is equal to 3 into capital N minus 4, capital N minus 1 which is equal to 4 minus 2 into 4. So, 1 minute. Yes, how many pairs are there? Pairs, lowest pair which is equal to 6, because here 3 joints are there. Pair 1, link 1 and link 4 joint at point A, 1 pair, and link 1 and link 5 joint at the same pair. So, A la 2 joints are there, C la 2 joints are there, right, and B la 1 joint, D la 1 joint. Okay. So, 2 plus 1 plus 2 plus 1. So, 4 plus 5 6. So, L which is equal to 6. So, here L which is equal to 6, 2 into 6 which is equal to 12, and see 12 minus 12 which is equal to 0 for this case, right. And what about last case? 6 bar mechanisms. So here n capital N, which is equal to how many links are there? Totally 6 links are there, right? Then what about L? L, which is equal to here 1 2 2 2 2 2, right? See, totally how many? 8. Clear? And how many links are there? 6 links. So 6 minus 1, which is equal to 5. So 3 into 5 minus 2 into 8, which is equal to 16. So how much? This is 15 minus 16, which is equal to minus 1. So n is less than 0. So minus 1, the degree of freedom for this 6 bar mechanism, which is minus 1. So it is a superstructure, right? Next, let us solve with higher pairs, right? So here how many links are there? Link 1, 2, 3. So totally 3 links are there. So capital N, which is equal to 3 links. Okay. Then what about L? L, which is equal to lower pair. How many lower pairs are there? 2 lower pairs, because the link 1 is joined with link 3 and link 1 is joined with link 2 by pin join. So totally 2 lower pairs are there. L, which is equal to 2. And how many higher pairs? H, which is equal to, see, link 2 and link 3 joined at this point. This is a point contact. So 1 higher pairs are there. So what is the formula? Already we know that n, which is equal to 3 into number of links minus 1 minus 2 into lower pair minus h, right? So what is this? 3 into 2 minus 2 2s are 4 minus 1. So 6 minus 4 minus 1. So n, which is equal to 1 for this first case, right? So see here, 6 minus 5, which is equal to 1 for this case. So n, which is equal to 1 for this case. This is a constrained mechanism. Then what about this second case? How many links are there? Totally 1 2 3 4 links are there, right? So capital N, which is equal to 4, right? Then what about lower pair? How many lower pairs are there? See, the link 1 and 2 joined at this point by pin joint, and link 2 and 3 joined at this point by pin joint, and link 3 and link 4 joined at this point by pin joint. So totally L, which is equal to 3, right? And how many higher pairs? See, link 4 and link 1 joined at this place by line point or line joint. So higher pair, which is equal to 1. So substitute this value. Now n, which is equal to 3 into 4 minus 1, 3, right? Minus 2 into 3 minus higher pair 1. See, 3 3s are 9 minus 6 minus 1. So how much? 9 minus 7, which is equal to 2, right? See, 4 total links and 2 into 6, 3 lower pairs and 1 higher pair. So totally n, which is equal to 2. It's an unconstrained mechanism, right? Now let us discuss Grubler's criteria. Grubler's criteria is applicable for the degree of freedom which is equal to 1, right? So where the overall mobility of the mechanism is unity, right? This Grubler mechanism is applicable for 1 degree of freedom, right? So let us take the Kutzbach criteria equation. So n, which is equal to 3 into n minus 1 minus 2 p1 minus 1 p2, right? Now substitute n, which is equal to 1 and p2, which is equal to 0, because here there is no higher pairs. We are considering only lower pairs. So this equation mathematically becomes 3n minus 2p1 minus 4, which is equal to 0. So this is called a Grubler criteria. Now let us substitute for 4 bar mechanism. Let us check this Grubler equation for 4 bar mechanism. Already 4 bar mechanism, n, which is equal to 1. We know that, right? See, take this Grubler equation. 3 into number of links, we know that for 4 bar mechanism 4. So 3 into 4 minus how many lower pairs are there in 4 bar mechanism? 4. So 2 into 4, right? So as it is, minus 4 in equation is there. So solve this, we got 0, which is equal to 0. This equation is suitable for Grubler 4 bar mechanism, right? Now let us solve this question. First one, determine the binary, ternary and quaternary links for the given kinematic chain as shown in the figure below, and also find the number of degree of freedom by using Kutzbach criteria. See, already we solved this problem. regarding this binary, ternary and quaternary, right? So there is no issue regarding this. Now we are going to calculate the degree of freedom with the help of Kutzbach criteria, right? We know that already the equation n which is equal to 3 into capital N minus 1 minus 2j minus h. So j which is equal to lower pair and capital H which is equal to higher pair, and n which is equal to number of pairs, right? I mean number of links, right? How many number of links are there? Link 1, link 2, this is link 3, link 4, link 5, link 6, link 7, link 8, link 9, right? So total n which is equal to 9. So n which is equal to, it represents number of links. Okay, now we are going to calculate j, number of pairs. How many pairs are there? So see, link 1 and link 3 joined here in this place, this is one pair, right? One pair, 2, 3, 4, 5, 6, 7, 8, 9, 10 pairs are there, right? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See here, 11 pairs are there totally, right? See, j which is equal to 11, right? And there is no higher pair, so h which is equal to 0. Substitute these values here. So n which is equal to 3 into n which is equal to 9 minus 1 minus 2 into 11 minus 0. So what is the value? N which is equal to 3 into 8 minus 22, right? Which is equal to 0. So 24, 3 8s are 24 minus 22 which is equal to 0. So n which is equal to 2, right? Let us check. See, n which is equal to 9 and j which is equal to 11 and h which is equal to 0. So what is the total degree of freedom for this given figure? 2, right? This is how we are going to solve each and every problem. Now let us try this different problem. So first we have to calculate the degree of freedom for this given mechanism. See, first write the equation small n which is equal to 3 into capital N minus 1 minus 2j minus h. So here there is no higher pair, so leave it this h which is equal to 0 for this case, and second case is also, right? So here also h which is equal to 0, right? So now count the number of links. Here as we see this picture, see totally 8 links are there, right? So link 1, 2, 3, 4, 5, 6, 7, 8 links are there. So n which is equal to 8, we know that. So 3 into 8 minus 1 minus 2 into how many pairs are there? See, first we have to calculate here. See, 1, 2, 3, 4, 5, 6, 7, 8, 9. See here 10, 11. 2 connections are there. See, link 8 and link 6, that is one pair, and link 6 and link 4, that is another pair. See, totally 11 pairs are there. So 2 into 11. See, what is the value? 3 into 7 minus 22. So 21 minus 22 which is equal to 21 minus 22 minus 1. See, so n which is equal to minus 1. So this is the superstructure or intermittent structure, right? So let us try this. See, n which is equal to 10, we know that up to 10 numbers are there, so automatically n which is equal to capital N which is equal to 10, and j which is equal to totally how many? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. See here the link 7 and link 8 both are connected at point A, and here link 3 is also there. Link 3 and 7 is also connected in the same point. So here 2 pairs are there, right? 2 pairs are there. 2 pairs are there. Similar to that, here 2 pairs also there. See, link 2 is connected with the link 1, and this link 5 is connected with this here link 1, right, at the same point B. So that's why here 2 joins are there, I mean 2 pairs. See, totally how many pairs? 13 pairs are there, right? So here 9 plus 4, which is equal to 13, right? So there is no higher pair, so that's why h which is equal to 0. Then substitute this n value 10 and j value 13. See, finally you got degree of freedom which is equal to 1 for this particular case, right? Now let us solve this. How many links are there? Kaplan, which is equal to totally how many numbers are there? Finally 8. So 8. So how many j points are there? See, 1, 2, 3, 4, 5, 6, 7, 8, 9. See, 9. This is 8, and there is no higher pair, so h which is equal to 0. So p2 which is equal to 0, and number of degree of freedom which is equal to 3. And in this case, see, number of links which is equal to n, because higher value of numerical value here 9 is there. So n which is equal to 9, and j which is equal to 10, and there is no higher pair, that's why 0, right? So how 10 comes in this? Because this is 1 pair, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So that's why j which is equal to 10 lower pairs, right? Substitute these n value and j value, then finally you got degree of freedom which is equal to 4. Okay, and now let us try with higher pairs, right? So this figure, it gives the details of the pulleys and belt drive, right? So 2 pulleys are there, pinion and gear, or driver and driven, right? So this is the driver and this is driven, right? So driver is connected with link 1 and driven is also connected with link 1. So these 2 connections are lower pairs. And how many links are there? Totally 4 links are there. See, driver is first link, and driver is pivoted with the link 1. So the pivot point is the link 1, and driver is link 2, and belt is link 3, and driven is link 4, right? So n which is equal to 4. And how many pairs are there? Lower pairs. Here the surface contact or area contact. See, the driver and driven connected with the link 1 with pivot point. So this is a lower pair. So 2 lower pairs are there. So j which is equal to, how many higher pairs are there? Here point P1, P2, P3 and P4. So all these 4 points at which the belt enters and leaves. So at P1, P2, P3, P4 is a line contact. So higher pair which is equal to 4, right? So substitute these values in this equation, and finally you got, see, number of links which is equal to 4, and lower pair which is equal to 2, and higher pair which is equal to 4. See, finally we got degree of freedom which is equal to 1, right? So finally the last one, how many pairs are there? How many links are there? See, Kaplan which is equal to how many links? See, 1, 2, 3, totally how many links? 6 links are there, right? See, 1, 2, 3, 4, 5, 6 links are there. So n which is equal to 6. So how many pairs? See, 1, 6 is one pair. 1, 6, 1, 2, 3, 4, 5, 6. So 6 pairs are there. There is no higher pair, right? See, totally 6 links are there. This is 6 links. And how many lower pairs? 7 lower pairs are there, right? 7 lower pairs. See, here one more, we forgot to add this. See, 1, 2, 3, 4, 5, 6 and 7. See, totally 7 links are there, right? 7 links, and there is no higher pair, so this becomes 0, and totally the degree of freedom which is equal to 1, which means it's a constrained motion. Okay, so thank you for watching. Thank you. Remaining things we will discuss in our next videos. Thank you.